Kia ora Year 12 and Year 13. This is a practice task for the Trig internal, and I'm going to go through it quite slowly. So we've got two different coloured graphs, and one is red and the other one is blue. And if you're doing this in class with me, you've got a black and white copy. So I'll just show you which one's red and which one's blue. Pretty obvious on here. Okay, so just from looking, the red function looks like a pretty nice, straightforward trig function. The equation of the blue function, though, is given by this function here. Okay, so it's a combo. It's got -3 cos of 2x, take away 3 sine x, take away 3 cos x. And the first thing you should be thinking is, well, I bet we're going to have to figure out what the equation is for that red function. And you'd be right. Okay, so we have to investigate the intervals between which the red function lies below the line y equals 2 on this domain. And then we also have to investigate for what possible values of x do the two functions, red and blue, have the same value. So let's just put in the line y equals 2 and see what we're trying to do with that first part of the question. Okay, so we are looking for the intervals between which the red function lies below the line y equals 2. So we're first going to find the intersections, and there'll be 4 of them. And then we're looking for this area here. So what are these x values? Here and here. Right, so 3 steps to solve this problem. The first step is going to be find the equation of the red function, which we'll call g of x. Second step is to solve g of x is equal to 2. And then I guess the third step is to find the regions, because we're figuring out where it lies below the line. And then we have to figure out for what possible values of x do the red and the blue functions have the same value. So for that part, we're going to need to solve f of x is equal to g of x, and f of x is what they've called y. Okay, so 4 things to do. So I'll just clean up the graph first. I'd like you to have a go at this before watching the video. It's fine if you watch each little step, but then you need to pause and give it a go on your own. Okay, so pause the video now and work out what is the equation of the red function. Okay, so let's just go through the features. So red function, period of the function, this goes from here through to here. So the period of the function is pi, which means that the frequency is the normal period for a sine or cosine function, 2 pi, divided by pi, which is 2. The amplitude, I'll get in a minute. The vertical shift is halfway between 0 and 6. So the midline is equal to 0 plus 6 over 2, which is 3. So that's the vertical shift. And the amplitude is going to be 3, right? So from the maximum y value of 6 down to the midline. And now we have to decide if we're going to model this with a sine curve or a cosine curve. If we model it with a sine curve, then we've got my starting point here. If we model it with a cosine curve, I'm going to have to deal with a horizontal shift. Sorry, I don't know why I did that, guys. So a sine curve is not going to need a horizontal shift. A cosine curve is going to need a horizontal shift out to here to get me to my starting point. So I'm going to choose a sine curve, right? Because that way there's no horizontal shift. And that means that I'm ready to write the function. So what did we call it? G of x will be 3 sine of 2x plus 3. So there's that done. Now the next thing I've got to do is figure out, first of all, where that red function is equal to 2. So we'll put that line in. Remember, what I'm looking for first is what are these points. And I know that you can get them on your graphics calculator, and that's a really good thing to do to check your answer, but we're going to do it by solving the equation g of x equals 2. So let's solve this. So again, pause the video, please, and find general and particular solutions for this. And we're looking for solutions in the range between, in the domain between 0 and 2 pi. Right, working through this line by line, we get 3 sine 2x is equal to negative 1. Sine of 2x is equal to negative 1/3. Now that tells me that I'm not working with exact values, because in my special triangles, I've got 1√3 and 2. I don't have 1 and 3. So I need to grab my graphics calculator, and I'm going to find the angle whose sine is negative 1/3. And just thinking about where that's coming from, a negative sine value is going to give me an angle down here in this quadrant here. And the angle will be negative 0.33984. So there's that done. And now we get 2x is equal to n pi plus negative 1 to the power of n times negative 0.33984. That's using my general solution formula for sine. But we need that for x, not for 2x. So x is equal to n pi on 2 plus negative 1 to the power of n times negative 0.16992. Okay, so that's my general solution for where the red function is equal to 2. The next step is to get the particular solutions, so to get the coordinates for these 4 points. And to do that, I'm going to substitute in values of n. So we call this particular solutions, or PS. So for n equals 0, x is equal to negative 0.16992. Sorry guys, that's not COVID. I have just done a rat test. Just got a cold. So x is equal to pi on 2 minus negative 0.16992, which is 1.7407. And I'm doing all of this out to about 4 dp, right? So don't round it too hard. So that's the first value found. And then for n equals 2, we get x is equal to pi. Right, this bit here will be a plus. So it's going to be pi minus 0.16992, giving us 2.9722. Guys, I'm really sorry this video is so boring. Please don't hang up the video because I'm coming to the tricky bit. So x is equal to 3 pi on 2 plus this, which gives me what? 4.8823. And the last value that I'm getting is 2 pi minus 0.16992. Now, we want to be careful that we haven't either somehow got an extra one or lost one. So let's just go and see on my graph if that all makes sense. So go back to the graph. And just let's have a look at those numbers. So there's my first one of 1.747. That looks about right because that's a bit over pi on 2. This one here, 2.9722. That looks good because it's quite near pi but below it. And then do the same for those last two. So the regions that we want to find where the function is below y equals 2. I'll just change pen color. So we're looking for these bits in here. Okay, so my final answer is going to be a sentence saying something like red function below y equals 2 for which values? Well, we've got x between 1.7407. That's probably a strict inequality actually. There we are. 2.9722 and also for 4.8823. Okay, so I'm just wondering if I might do a second video to do the last part, and I think I will, because the second part is more involved, right? We're going to have to equate this with the red function. So I'm going to stop this one now and do a part 2 video where we do some slightly harder work that is going to involve identities, and then again solving and finding general and particular solutions. So thanks for watching, and I'll be back soon with the harder part of the problem.